This is Dr. Holt. This is AP Physics C. This lecture is on impulse. When we think of Newton's second law, we always usually want to think about force net is equal to mass times acceleration. However, when Newton devised his second law, he considered the product of mass and velocity as a measure of an object's quantity of motion. Today we call the product of a particle's mass and velocity linear momentum. Now we can state that the force net is going to equal to the change momentum. Now momentum will be specified by the term or the letter P. So the change momentum over change in time will equal to force net. We can also say that the change momentum will equal to the product of mass times change in velocity. Now each of these are going to be vector quantities, the linear momentum and the change in velocity. Now if I take this line and divide it by delta P, we will get Newton's, what we state as Newton's second law, F equals ma. If I take this and divide this line again by delta T, then delta P over delta T is equal to force net as specified right here, so I put in force net here. If I take delta V and divide it by delta T, then I get acceleration here, and that gives me mass times acceleration. And that's what we're used to, that force net is equal to mass times acceleration. The quantity P, again to restate, is called linear momentum of a particle. Now to distinguish linear momentum from angular momentum, we use the term again P. Angular momentum we will cover in a future lecture. So this equation I'm going to be using quite a bit. Let me go back with that. Sorry, it bounces around on me there. That linear momentum is equal to the product of mass times v. I'm not sure why that bouncing around like that. Linear momentum is a vector quantity. It is a product of a vector velocity and a scalar mass. Its magnitude is mass times velocity, and it has the same direction as velocity. So when you're doing your specifying what direction the vector should go, it will go the direction that the velocity is going. The units of momentum are the units of mass times speed, or kilograms times meters per second. Momentum may be thought as a measurement of the effort needed to bring a particle to rest. For example, a massive truck has more momentum than a small passenger car when they're both traveling at the same speed. It takes a greater force to stop the truck in a given time than it does to stop the car in the same amount of time. Now when the sum of external forces acting on a system of particles remains zero, the rate of change of the total momentum remains zero and the total momentum of the system remains constant. So if I can say the summation of forces external is equal to zero, then the momentum is going to be constant. Let me bounce back with that. This result is known as the law of conservation of momentum. And to state that, here I have a system of different particles. Now they can interact with one another. However, if there's no external forces being acted upon the system itself, then the momentum of the system will remain constant. Now the impulse, again, is a vector quantity, and the impulse of a force during the time interval delta t from t final to ti is a vector defined as the integral between ti and tf of f dt. That will define the value of impulse. Now the impulse momentum theorem for a particle says that the impulse net is going to equal to the change momentum of the system itself. And then to state it overall, the impulse momentum theorem again is stated as the impulse is the integral of f dt between the two limits of time, or equal to the change momentum of the system itself. Now you get into instances where the force is not constant, where the force varies or is a function of time. Now when you get into situations like that, your impulse will represent the area under the curve here. Now to find the average force, what we would do, we would use the average equation of 1 divided by the difference between the two time intervals, multiplied it by the area under the curve, or the integral between t1 and t2 of the function times dt. Now that would give the average force. Now when you, like say you're going to jump off the ground, you would find out that your impulse would look something like that. If you wanted to determine what the average force being applied, then you could use this equation right here to do that. I'm going to work one example problem here. The first problem here, I have an average force of 10,000 newtons is exerted for 5 seconds on a 1,000 kilogram object that is rest. What is the impulse of this force for 5 seconds? Question 2, what is the 1,000 kilograms object change momentum? Question 3, what is the change in velocity from this impulse? Question 4, what is the object change in kinetic energy? We go back to the equation that impulse is equal to the average force times change in time. Now my change in time is going to be for just this 5 seconds, and the average force is 10,000. So it's just going to be the product of 10,000 times 5. That gives me 50,000 newtons seconds. To answer question 2, what is the 1,000 kilogram object change in momentum? Well, we know that the change momentum is always going to equal to the net impulse, and the net impulse that was applied was just the 50,000 newton seconds. So these will have exactly the same values. Question number 3. What is the change in velocity from this impulse? Well, we know that the only change in the impulse here is going to be what here was the 50,000, because my initial impulse, the object was at rest here, so the velocity initially was 0. So the change in impulse would have been the 50,000 newtons seconds subtracted from what I had in the beginning. Now note here that newton seconds is the same thing as kilograms times meters per second. The units would be converted the same, because newtons here is nothing more than kilograms times meters per second squared. If I multiply by seconds, and then I will get I'll get kilograms times meters per second. So the velocity here, we just take 50,000 newton seconds. We set it equal to the mass, 1,000 kilograms we solve for v, and we will get v as 50 meters per second. And then question 4, what is the object's change kinetic energy? Now we know since the object was at rest, the initial kinetic energy was 0. We just go back to the kinetic energy equation, 1/2 mv squared. We put it in the units for mass, which is 1,000 kilograms. Our velocity was 50. We square that. We will get 1,250,000 joules. Alright, this is one example problem I worked. I hope you find this lecture and this problem I solved useful. Best of luck.